Where did we all come from? You've probably heard of and understood the Big Bang as a massive explosion that kickstarted the evolution of the universe. And once a whole lot of time passed, enough particles in our explosion collided to fuse the heavy elements that we're familiar with today. The Big Bang is a description of how everything started as a single point of infinite density that eventually inflated and expanded. That is, started as, not started from. It was the entirety of the universe expanding after being compressed. So the universe, the fabric of everything we see, was the Big Bang. But it was in this very first, early primordial soup that we initially had nothing but quarks that then turned to baryons that eventually became the simplest building blocks that rest within our stellar cores, fusing and, with the assistance of quantum mechanics, continuing to supply solar systems across our ever-expanding universe, until we reach our limits. What I'm referring to here is something called the cosmological horizon, which is a measure of the distance from which we could be able to actually retrieve some information. This is often confused with the particle horizon, which is basically the maximum distance from which light from particles could have moved or traveled to whoever is observing it within the current age of the universe. This is where Webb comes in with its incredible study and wonderful instruments. It's a very powerful infrared observatory key to seeing the first stars that formed. After the Big Bang, obviously the universe created and emitted electromagnetic radiation. The issue with this is that it's no longer visible because the universe is indeed expanding as we speak. This also impacts the length, that is to say, the wavelength of light that was emitted, making it stretched out and elongated, which means that it's no longer part of the visible end of the spectrum. So it's thanks to these incredible filters and this massive mirror that spans an entire tennis court when fully unfolded that we will finally be able to see the earliest galaxies at the earliest stages of the universe, finally perhaps pinpointing an age that is definite for the universe and understanding how its expansion will impact its death.